All right. Hello, everyone. My name is Edin Taric. I've been working with Robot Framework for about 2 years now as a developer working for the company INSYS icom. I'm going to talk to you today about a program that I've been writing for about 1.5 of those years, slowly on the side in between, and a bit more intensively over the past half year. And essentially what it does is it's another solution to executing test suites in parallel. I'll get into the details of that in a second. First, let's talk about why we need to parallelize, like what's the use case for this. So as I mentioned, I work for INSYS icom and we build industrial routers. You can see a few of them on the slide. And there's some quite different looking ones. There's the ones on the right that have a bunch of slots. And yes, they are modular, and modularity means more testing because there's lots of combinations of hardware to cover. And of course, their routers, they have a bunch of features like VPNs. There's LTE networks, there's different modem compatibilities to keep in mind. So yeah, there's a lot to test. And all of our hardware and software is developed in-house. And we also do all of the testing in-house as a part of that development process. Each and every day, we have a new build increment that gets tested. And yeah, that is supposed to happen every night. Now, the problem with that is, the problem with that is that it takes a while. We have many tests. We have around 1,500 that need to run every night currently. We have many devices. So we have a test setup of a wall that is about as wide as the stage, full of different routers and different configurations that are connected with each other or just on their own. And doing all of this takes a while. To be a bit more precise, it takes around 50 to 60 hours because even if you consider like a UDP port scan or something, that alone takes many hours. So yeah, the fundamental problem is you obviously can't do daily testing if your tests takes 2 days. So yeah, our solution to that first was Parbot. Parbot exists, so the question is now, why did we need a new tool? Parbot can run suites in parallel. It can run tests in parallel even, which is something Medusa can't do at this point. It also has a concept of dependencies, so you can say this suite depends on another suite to run first, or perhaps a test depends on another test to run first. You can also split execution up into stages, and I'm sure there's now also a bunch of new features that I'm not aware of. But yeah, at the time we had the problem that suite-to-suite dependencies don't map very well to our use case. Since we're testing hardware and we have physical devices, but we have lots of suites that use some of these devices. So let's say we have one suite that tests Ethernet ports or something. We might have 2 devices connected to each other. So the test can be said to have a dependency on those 2 devices. Or we have a test which requires a certain local port on a test PC. So we have a dependency on that port. Or we have one DSL connection. So we have a dependency on the DSL connection. We can't have 2 DSL test suites running at the same time. And yeah, this model of dependencies doesn't map very well to suite or to suite test-to-test dependencies. So we decided to just use a different approach for this. And yeah, because we found that writing a script around Parbot to write some kind of ordering file that makes it work was not very robust and still took longer than we wanted. So yeah, this is the Medusa in one slide pitch. We have, instead of configuration files, we just note the dependencies and stage and all these things in the metadata of each suite, so it becomes relatively easy to manage and robust. Underlined here you see the different metadata types. So first we have the stage and the dependencies, deps in this case, which are the only mandatory types of metadata that Medusa expects. And yeah, a stage allows you to basically run all your tests in sequential batches. So you can maintain some kind of order. And within each batch, the test suites are potentially all running at the same time if their dependencies allow it. And that's how you get to the dependencies. The dependencies are used for conflict prevention. So if two suites have a dependency on the same device, for example, or essentially it's just strings. So if two suites have dependencies on the same string, then Medusa prevents them from running at the same time. And Medusa handles this dynamically at runtime. So whenever one suite finishes, Medusa evaluates whether another one can be started with the dependencies that were freed up. Then we get to kind of my favorite feature, which is this Medusa for. As the name indicates, it's kind of like a for loop over a suite. Essentially, Medusa duplicates the suite or multiplies it and allows you to run one suite multiple times with multiple arguments, with multiple variables. So what we are using this for is, for example, we have different device families. These device families might have completely different hardware and even a completely different CPU architecture. So yeah, our solution for that is, since all of our devices are still supposed to run the same firmware and work in the same fundamental way, we want to be able to run the same test suite on all of them. And for this, we can use this to avoid code duplication. So we just instruct Medusa to run one suite several times with different targets, essentially. And I guess you can imagine that you could also use this for other things than just device testing specifically. At last, we have another small one that's not as important, but a nice to have, which is timeouts. This is also something PowerBot can do. In our case, we also have suite-specific timeouts with this metadata and a configurable default on the CLI. Now, let me show you what this actually looks like in a suite. So here we have an example suite. You can kind of ignore the test case and the keywords, since it's just kind of sleep and log what happened. So what you can see at the top is we have the two mandatory types of metadata. We have a stage 1 in this case. We have two dependencies, which are the variables sender and recipient. So as you might guess from this, Medusa resolves variables in the dependencies, or generally in the metadata that it supports. And so this will be expanded to a suite in stage 1 with the dependencies bar and foo. Now, another option that you can use is, of course, using list variables for dependencies. Like it's an obvious convenience feature. So the way that this suite is written is equivalent to the previous suite. So Medusa just expands and flattens the list into a series of single dependencies. Now, this is a slightly more complex example because there are many cases where you don't particularly care about which of a group of items is picked. In our case, I was talking about families of devices. If we want to make sure that something works on all families, we might not care particularly much about which device from a group of devices of that family it runs on. And in fact, we would be very happy if we don't have to manually specify that, because everything that you manually specify is something that ages. You add a new device, and you add another new device, and you'll find that the old devices are used a lot more than the new ones. So this is one way that you can just make Medusa choose something dynamically if you don't care particularly much what's used. You could also use this, for example, if you wanted to pick from a range of IP addresses. You could have a list of allowed IP addresses to pick from, or ports, or something else. Yeah. The goal of this is, again, flexibility and efficiency. Now, my favorite feature, which is Medusa for. Yeah, it looks like a for loop. It basically is a for loop. It uses similar syntax to Robot and Python in that you have a target variable, in this case DUT, the device under test, in a list of DUTs. So essentially you're instructing Medusa for each item in the list of DUTs to just pick one, assign it to DUT, and run the suite with that. So this suite is actually 3 suites. It will appear 3 times in your result. Once with DUT equals foo, once with bar, and once with baz. Then, yeah, let's run this. I prepared a little demo. And you can see the 4 suite examples that I showed you. And I'm just running Medusa run on the current directory. It shows you what's currently running, what's still pending because the dependencies are not available, what is finished. There's also verbose output where you would precisely see when suites are started and finished, etc. And then there's a bunch of other stuff. So let me tell you what that other stuff is. So at the very top, you can see processing suite data. Essentially, the way that Medusa works is before running any suites, it performs a dry run with its own listener. And the listener is used to collect data about all of the suites. This is the most robust way that I found to do variable resolution and all of these things in like basically the configuration, how it would actually be running. So to get the accurate and robust data about the suites. If all of that, so if something goes wrong at this step, your suites wouldn't even get executed. You would get a nice error message, hey, this metadata is wrong, or maybe even Robot Framework itself finds an issue during the dry run, so it would stop there. But everything's fine, so we start the execution, and we start the first stage. In this case, I only had 1 stage, so that's what we have. The stage is finished. Then there is a visualization, which I'll show you later what that looks like, which can be very helpful for debugging issues. And finally, all the individual results of the different suites are merged into one output XML, log HTML, and report HTML. Let's have a look at these results. So the first thing you might notice is we have, like in the previous video, there was a runtime of 13 seconds shown. In the report, you can see 18 seconds. So yeah, we had 6 suites. Essentially, we had 4 files, but one of the files equals to 3 suites. So we have 6 suites, which each sleep for 3 seconds. So you would expect an 18 seconds runtime. In this case, because Medusa runs some of these in parallel, we had a real runtime of 13 seconds. Another thing you'll notice is that for the Medusa 4 example, where it loops over the suite essentially, Medusa appends a random string to keep it unique in the results. Otherwise, you would get unintended behavior when you merge all the results. You would get it kind of like overwriting as if it were a rerun. So that's a workaround, but I'm still looking for a better solution for this, to have it not random, but deterministic, what appears there, and perhaps even human readable, but that's still a work in progress. So yeah, what exactly happened with the suites? In this case, we have the second example, which used the dynamic dependencies. So in that example, we instructed Medusa to pick 2 values from a list of 4 values. So what you can see here is that Medusa rewrites the metadata before executing to reflect the values that were actually chosen for the suite at runtime. So in this case, we have the dependencies bar and foo that were selected from the 4 options. So that is what the test was executed with. Then we have Medusa 4. Here I'm just showing 2 suites because 3 didn't fit the screen very nicely. So yeah, there you can see that the dependency is correctly reflected. The Medusa 4 value is kind of reflected as well. So it shows that it assigned the foo to the variable DUT in the first one and baz in the second one. And yeah, the variables are also injected into the suite to make the tests run properly. Then we have the visualization, which is also something I recently added. This stems from a practical problem. Like the basics of how Medusa works has been available for we've used it for about 1.5 years now, from when I first developed it. But we found that we would sometimes have funny test failures, and it became very difficult to figure out whether there was knock-on effects between different suites. Like, let's say we had one suite that failed, but the failure was caused by the previous suite misconfiguring the device in a way that it was not reachable anymore afterwards. So for this kind of thing, it's very useful to have a timeline of how things happened. And that's what this is. So first, you see we have a little stage marker, which just shows you where a stage started. If you have multiple stages, that can be very helpful. And of course, in our case, we would have like 50 rows and a lot more columns spanning about 5 hours of time. So it would be a slightly different looking graphic in a real world use, but yeah. Then another thing that you can do, of course, in this is you can hover over these bars. You can see on the bottom is the time axis, as I mentioned, and on the left we have the dependencies. So in this case, we have a suite that spans the dependencies bar and foo. And yeah, you get some information about it, about the tags, when it was started, when it finished, and which other dependencies are part of it, etc. And it is kind of highlighted. This is just a simple SVG graphic with some CSS to make the highlighting possible, because that was kind of the most simple and flexible solution for us to start with. And it would also make it quite easily embeddable into web pages or other kinds of reports in the future. So yeah, here's another example. This is one of the Medusa 4 iterations. You can see that because it had a different dependency, it was able to run in parallel with the previously hovered suite. And each color in this example reflects a different suite. Now we get to the timeouts, which is also something that was useful to us because we're testing real devices. Real devices sometimes suffer from timing issues, or there might be issues with like talking to a device over SSH or something. We had a particular problem that SSH sessions would get stuck sometimes. And yeah, so for cases like this, or for cases where perhaps an external program fails, but it fails in a way that your suite just hangs, sometimes a test timeout might not be enough. For example, if the problem occurs in the suite setup or suite teardown. So for this reason, in Medusa, I also introduced a suite timeout. And this is essentially 3 timers that you can specify in seconds. The first one is a soft timeout. So after the first one, Medusa sends an interrupt to the process. And then Robot Framework is smart in how it handles interrupts. And on the first interrupt, it would usually skip to teardown. If it's still not finished after the second number, in this case 30 seconds, then it would get a second interrupt. And at this point, robot should quit immediately. And of course, then the third value is the bad one, which is the kill timeout, where Medusa just kills the process if nothing happens. I haven't found a case where I really needed the third one, but it's good to have it, I guess. The way, one thing to keep in mind with this, of course, is if you interrupt the way that a suite normally runs, you might not get valid results at the end out of that suite. So you might get corrupt XML if you send 2 interrupts to Robot Framework, because it will just stop. And the way that Medusa deals with this is by just making it very visible when something generated invalid output. So during the merging process, Medusa will recognize if Rebot fails to merge the results, and it will log the failed merges to command line. It will still merge all of the valid results together, but the report will also be named differently to indicate very clearly that something is wrong in this run. So but wait, there's more. Medusa 4 can do a little bit more than just what I showed you. It can also assign to multiple variables. Let's say you have a list of lists. Let's say you have 3 variables that you want to assign to. Then you could have a list which contains 3 other lists with 3 elements each, and then each element would get assigned to one of the variables. And of course, the same thing also works for dictionaries, which is also very convenient. There is also a stats command, which basically just does the reading the suite part and then outputs some information about the suites. And lastly, we have a filter option. So this just allows you to modify what is actually executed. So you could filter by dependencies, you could filter by the stage. And yeah, another great thing is that I designed Medusa in a way that it basically works like a wrapper around robot framework. So most of your regular robot options can just be specified to Medusa. For example, you can use listeners, pre-run modifiers, you can use filtering by tags and other things like that as normal. And Medusa will keep that in mind when it executes things. And yeah, that is it for me. Medusa was published about 1 or 2 weeks ago under the Apache 2 license. It is one case in which the project was not planned from the beginning to be open source, but that is, I managed to convince my company to open source it. And yeah, I am very curious to hear how you will use it, because for me this is, first of all, this is my first talk at a conference like this. This is my first RoboCon, and this is the first project that's like a serious thing that we actually use for something that is being released. So I'm very happy to hear your suggestions and feedback. And yeah, thank you very much.
Thank you for the talk. We'll take questions while we pass the mic. I have a question, but I have to say first that Rene told me that I've hit the limit with bad jokes for today. So this is not a joke, this is a proper question. So in Greek mythology, Medusa, it turned things into stone. Your Medusa is turning sequential tests to parallel tests.
Yeah, it
kind of a different vibe. Maybe
yes.
A weird vibe with the name, but why the name?
So I've never been good at naming things, but that aside, it was less about the Greek mythology and more about the, less about the person that Medusa was, and more about the looks. I mean, snakes, Python, and many snakes, so it's parallel and all that. And the good name Pabot was already taken, so I really had to. Yeah, I really had to dig deep for that. If you have naming suggestions, please go ahead.
No, it's a good name. It's a good name. So let's take the first question from there.
Okay, my question is can Medusa also handle things like wrapping, instead of wrapping around a robot, wrapping around something like robot code, which will execute robot for the use case of using profile configurations?
I have not tried this. I don't think so. It was designed pretty clearly as a wrapper around robot, but it could possibly be adapted to that. So let's talk afterwards maybe, because I'm also curious to hear about it, yeah.
More questions? There.
I'm just curious, does it allow to distribute execution between several servers?
No, that's not. At least, I mean, you're welcome to contribute, PR. No, at this point, because our use case at my company, the devices are the speed bottleneck, and the protocols that are involved, and then interfaces like networking and LTE and stuff, all that stuff is so slow that distributing load over multiple machines was not a design consideration, but it's something that, of course, I would be happy to hear suggestions about.
More questions? There, up there.
Yeah, just a quick question. It sounds like a really useful feature for your specific use case, and I understand where it's originated from because you couldn't open source at the start. But I'm wondering, are you also looking into collaborating with Pabot so we get the best of both worlds? Because it feels like you're making new features and, well, maybe you get requests that are similar to stuff that's already available in Pabot to prevent you from reinventing the wheel, so to speak. So I'm just wondering what your thoughts are on that.
Yeah, I mean, to be honest, when I started this 1.5 years ago, I didn't think it would escalate quite this much. Like Medusa 4 and these kinds of things were later additions. The dynamic dependencies are a very recent addition. The visualization is a recent addition. It was first just intended to fit our internal use case, and that's why, yeah, it came into existence. But of course, if there is a way that it can still like join with the power of Pabot, then I would be happy to explore that.
Interesting. Thank you.
Thanks. We have time for one more question if anyone has one. Then it's time for coffee. Thank you, Eden.
Thank you.